So this is a question from 2023 CSAT. So the question basically asks you which is the 10 raised to 10th day. So what you have to understand is that this is a mix of reminder theorem and calendars. First of all, I want you guys to pause the video and try to answer this question yourself, because you cannot learn maths until you make enough mistakes and until you try to solve. Trying to solve the answer even without getting the answer itself is a very big step of learning maths. Now, hope you have tried. I'm going to give you the answer. So what you have to understand is that in calendars, we know how to find the days or after some days. That basically means is that what UPSC want you to understand is that according to UPSC, the starting day is considered as the first day. So they are saying today is the Sunday, and they are basically telling you that first day is Sunday. That basically means that second day will be Monday, 3, 4, 5, 6, 7, that is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and it keeps on going. The next set will be 8, 9, 10, 11, 12, 13, 14, and keeps on going. So the basic principle which we need to know is that, imagine we have to find which is on the on the 12th day, or if today is Sunday, which is on the 12th day. What you have to do is just use the basic principle of calendars. That is 12th day you have to find, subtract the day which you know, that is first day which is Sunday, whole divided by 7, because there are 7 days in a week. Now you have to find the remainder for this thing. So before finding remainder, what you have to do, you simply have to find the remainder, that is 11 by 7. If you take 11 and divide it by 7, 1 times 7 balance, you will get remainder as 4. If you get remainder 4, that basically means that you have to add 4 to the Sunday, that is Sunday plus 4 day. 1, 2, 3, 4. Sunday plus 4 day, 1, 2, 3 and 4. So the 12th day will be exactly on Thursday. So this is the principle. Now we simply have to apply the same thing in our case. Sunday, Monday, Tuesday, Wednesday. But here we are not looking for the 12th day, we are looking for 10 raised to 10th day. So before going to that, let me tell you one more thing. So what you have, the formula which you just used is that end date minus starting date divided by 7, and you have to find the remainder, and simply you have to add that remainder to the starting day. For example, you don't know which is on the first day. Imagine your case is something like you know that 4th is Wednesday, you have to find which is on the 13th. Okay, so you have to do is ending day is 13 minus 4 divided by 7. 13 minus, you will get 9 by 7, and 9 by 7, it will go 1 times 7 balance 2. So you simply got the remainder as 2. So that basically means that you have to add 2 to Wednesday, that is Wednesday, Thursday, Friday. Okay, so it's as easy as that. Now by applying this same formula, we can find what comes on 10 raised to 10th day. So let's start doing that thing. 10 raised to 10 minus, that's ending day, minus 1 by 7. So I'll apply remainder theorem. According to remainder theorem, if I do 10 divided by 7, 1 times 7 balance is 3. The remainder will become 3. So I'm going to, instead of this 10 raised to 10, I'm going to write 3 raised to 10 minus 1 by 7. So what remainder theorem basically says is that the remainder of this thing will be same as remainder of this thing. Why did I just replace 1? Because 1 divided by 7, 0, 0, remainder is still not 7, remainder is just 1. So according to remainder theorem, the remainder of both of this stuff will be same. Now to go further, I'll use a trick. What I'm going to look is that I'm going to see if is there any number which is close, is there any powers of 3 which is close to the multiple of 7. That basically means that 3 raised to 1 is 3, 3 square is 9, 3 cube is 27. Yes, 27 is there. How is it close? I can say that this is close to 28, which is 7 into 4. So I'm going to convert this 3 raised to 10 into 3 cube. So how to do that is 3 raised to 10 basically means 3 raised to 9 plus 1, which is 3 raised to 9 into 3 raised to 1, which is 3 raised to 3 into 3 into 3 raised to 1. 3 into 3 basically means 9. So before that, how did I split this thing from here? A raised to x plus y simply means a raised to x into a raised to y. Similarly, now I am going to do something more. I am going to convert this thing into something like this. Why can I do that? I can do that because a raised to x whole raised to y is simply a raised to x into y. So same thing. So this thing eventually will become there is no space enough. That thing will become 27. 3 cube is 27 cube into 3 raised to 1. So now I am going to replace this value. Once I replace that value, I am going to get 27 cube into 3 raised to 1 or 3 minus 1 by 7. Now I am again going to apply remainder theorem. 27 divided by 7, 4 times 28 divided by minus 1. See, you cannot do that. Basically, when we do normal division, it will be like 27 will go 3 times, that is 21, and balance will be 6. That is a normal division. But here I am doing a trick. I am going to say take it one step further, and I am going to say it will go 4 times 4 into 7, 28, remainder is minus 1. Remainder never should become minus 1. This I am doing because it's an intermediary step. So here it is going to become minus 1 whole cube, and 3 divided by 7, this part. 3 divided by 7, it's 0 times 0, remainder is 3 into 3 minus 1 by 7. Okay. Negative number, negative minus 1 raised to odd number, that is 3. That is going to become minus 3 minus 1 by 7. So minus 4 by 7. Now I can stop. Why? Because this value 4, that is less than 7. But the value is negative. I just told you remainder should not become negative. So if you go to something like this, then your remainder is going to be divisor minus whatever value which you got there. So that is, our divisor is 7. So 7 minus 4, that is 3. So the remainder which I got is 3. If I got a remainder 3, that basically means I have to, so today is Sunday, I have to add 3 days. 1, 2, 3. 10 raised to 10th day will be on a Wednesday, and the answer is going to be Wednesday. Yeah, it's a little bit tricky problem. There's nothing much we can do. In case you find any easier solution, please let me know in the comments, and thank you.